Good afternoon, everyone. Welcome to this first community day that ahedd organizes for the DIH World. It's one of the many opportunities we'll have to discuss digital transformation with SMEs and technology pioneers from the Greek ecosystem. I want to share with you the fact that digital transformation of the economy is a priority for the European Commission. It's the focus of the Digital Europe program, and the European Commission have chosen the network of the European Digital Innovation Hubs to facilitate the digital transformation in every country. Among the main objectives of ahedd is to provide testing facilities to SMEs for their own experimentation, training in both technology and skills, to facilitate them meet and seek synergies with other European countries, SMEs from other European countries, and also help them to finance their efforts via several different ways, open calls, but also in the frame of the European Digital Innovation Support Program. Don't forget that ahedd is the coordinator of the big consortium of Smart Attica that is a candidate of the European Digital Innovation Hub Network. This will help us improve a lot and empower our efforts to make through the digital transformation of the Greek economy and the ecosystem. Thank you very much for being here with us.
The world is always moving, always changing. Keep up transforming your organization digitally and stay ahead. Improve your processes, products and services through digital technologies and you will increase profits, increase agility, improve productivity, increase visibility, move faster. Digital innovation hubs are not-for-profit, one-stop shops that support companies, in particular SMEs, and public organizations in their digital transformations. SMEs can benefit from digital innovation hubs to better understand how to improve their processes, products and services through digital technologies. DIH-World aims to accelerate the uptake of advanced digital technologies by European manufacturing SMEs in all sectors by supporting them in building sustainable competitive advantages and reaching global markets. DIH-World strengthens the capacities of regional DIHs, particularly in underrepresented regions across Europe. The project is coordinated by CASA and supported by Interlara Consulting, Improve, Innovalia Association, Eurada and CBT. In addition, the project involves 27 digital innovation hubs from 26 countries and 8 SMEs from 6 countries to develop 8 pilot experiments. The aim is to grow the community to include more than 70 DIHs and 50 SMEs. To reach this goal, DIH-World is launching 2 open calls for consortium seeking innovative experiments conducted by 1 SME and 1 DIH. The first one took place in April 2021 and added 35 experiments to the project. And the second one, in April 2022 and will add 20 experiments. Information on the open call will be presented during the Community Days, events in 26 countries across Europe organized by all the DIHs in order to connect DIHs with their ecosystems. From 18th April to 15th of May 2022, you will get experiences and cases in this double transition and how DIHs can help you with this procedure through their services. Don't think twice. Act.
Hello everyone, thank you for being with us here today. I'm going to talk to you about the ahedd the Attica Hub for the Economy of Data and Devices. ahedd is a digital innovation hub. As a hub, it is an ecosystem of partners. The ecosystem is orchestrated by NCSR Demokritos, the largest research center in Greece. It is supported by the technological park Demokritos, hosting more than 40 innovative companies. Currently, we have collaborations with Sci-Fi, Think, Link Business, and SCIO, but we are also exploring synergies with more companies. We have industrial partners such as two large associations of companies, the SEP, the Hellenic Federation of Enterprises, and SECE, the Hellenic Association of Innovative Application Companies. We have also partnership with Vodafone, with Helix. I will tell you a little bit more about these two partnerships later on. And we are also collaborating with an ecosystem of companies that belong to Obscene, exploring some use cases for smart cities. We are also coordinating a consortium that is a European Digital Innovation Hub candidate. It's called the Smart Attica, and I will tell you about that later on as well. Apart from our collaborations at a local level, we are members of international and European associations and networks, such as the Big Data Value Association, an industry-driven international association, which has awarded us the Gold Label for our maturity and impact in providing data-driven solutions. We are members of the European Digital SME Alliance, the largest network of ICT SMEs in Europe, and also of the Scientific Association for AI, EURAI. We are also participating or coordinating projects that are providing solutions and technologies in the domain of AI and high-performance computing, such as the AI for EU, the AI for Copernicus, the EuroCC, Greece. And we are also members of some digital innovation hub networks, which are launching open calls for experiments with SMEs, such as the EU Hubs for Data, DIH-World, I for Trust, DIH for CPS, and DIH-Square. Our main expertise is in the fields of artificial intelligence, big data, and Internet of Things. And our vision is to become a reference one-stop shop for data-driven innovation solutions, facilitate the adoption of cutting-edge technologies, accelerate digital transformation, and increase SME competitiveness. Our main service areas are test before invest activities. That means we are deploying test beds and tools that help SMEs experiment with solutions and test solutions before they invest a significant amount in them. We are one-stop shop for specialized solutions. We support the co-development of products and services and the technology transfer through the exploitation of mature research results. We are also providing consulting and training sessions to promote digital innovation to companies. Now I'm going to share with you some of our activities. One is the Smart City Testbed that we are building in NCSR Demokritos campus in order to experiment with solutions. So in collaboration with Vodafone, we are deploying a private 5G network in the campus that can be used for experimentation. And also we are installing IoT sensors and connectivity solutions, for example, for temperature and humidity monitoring, for monitoring the occupancy of buildings and also of parking spots, for fleet management, and also for waste management. We are also exploring and deploying more solutions. In collaboration with Helix, we are implementing water management solutions across the campus. We are also exploring synergies with other SMEs mid-caps as providers, integrators, or users that can enrich or use the testbed facilities. The important thing is that the infrastructure and data are made available for R&D exploitation. That means that we can use the experience of our labs in AI in order to provide analytics, predictions, and support decision-making. The Smart Attica EDIH consortium that I mentioned to you about, it was ranked first in the national pre-selection in November 2020. It is currently being evaluated at the European level. It consists of 17 strategic partners coming from academia, like Athens University of Economics and Business, the National Technical University, the Institute of Communication and Computer Systems, in our research center. It is also supported by the National Documentation Center and the National Infrastructure for Research and Technology, as well as of Archimedes, the business unit of the National Laboratory University of Athens. It has also some partners that are supporting business-related activities, like the Foundation, the Hellenic Federation of Enterprises, the NASIS Foundation. And it is supported by companies that provide the necessary funding for deploying solutions, such as the National Bank of Greece and the Unfund Venture Capital Management Company. And it's also supported by the Prefecture of Athens and the Municipality of Athens and Hellenic corporations of assets and participations that will provide the necessary test beds and end users for our solutions. What is the focus of this effort? European digital innovation hubs aim to increase the uptake of artificial intelligence, high-performance computing, and cybersecurity technologies. They receive funding from both the EU and the member states. That's why they're being evaluated by both of them. Smart Attica focuses on 3 thematic areas that are energy and environment, supply chain and mobility, and culture and tourism. And the type of services that are provided through this hub are Test Before Invest, including infrastructures, data, and tools, training services, support to find investments, and networking. Thank you for your attention, and thank you for being here with us again. If you have any questions, please contact us, visit our website, and we are here to support you in this digital transformation journey.
Hello to all. My name is Evangelos Angelopoulos. I'm the CEO and Business Development Director of a deep tech company, Fuelix. We're here for the DIH-World Community Day that is made for the Greek ecosystem of IoT and AI companies in Greece. We're happy to present our company along with the findings of Smart Chain project, which is a project that was submitted in DIH-World and was successfully concluded. Just to let you know, we have uploaded our deliverables, so we're ready for the next step. Some things about Fuelix. Fuelix is an edge computing sensor manufacturing company that is doing R&D and at the same time development and the industrialization of sensors for the Smart City Initiative and the Fuel Management Initiative. That's why we're called Fuelix. A little bit things about us. As I said, we're an R&D company, meaning that we do everything from TRL 0 to TRL 9, usually with one iteration, meaning that we do save a lot of money in the development and the deployment of projects. We have been established in 2019, so we're a startup, a small deep tech company that is known for the term edge computing battery operated constrained devices, meaning that we do design and develop sensors that are only battery operated, and they have and they exhibit edge computing capabilities, meaning that they take on the field, they take they can understand and they can take decisions, normally sending notifications and alarms. So as I said, we love to develop products. So we have a portfolio of TRL9 sensors, meaning that most of the sensors have already a CE mark or a certification that allows them to be sold off the shelf. And we are focused on various smart city technologies, including fuel management, where we measure diesel, electricity, natural gas, water management for man-made tanks or natural tanks, waste management, parking management, wastewater management, and asset management. This is the last thing that we have been developed. And this is the Smart Chain initiative. We have a presence in the EU. We're based in Athens, Greece. But at the same time, we do have representatives in UAE, and we're doing business mostly in the Middle East and the UK. For now, of course, we do a lot of projects in Greece. So we are known about designing and developing low power wide area access network sensors, meaning sensors that do operate on mobile infrastructure, current mobile infrastructure. We are specialists on a technology called narrowband Internet of Things, which is a technology being provided by all telecom operators here in Greece and almost all around the world. So our sensors have the capability to even on narrowband, which is a very, very, very narrow throughput based data throughput based channel to be remotely configured, and at the same time we were able to over the air to do firmware updates, meaning that wherever the sensor is being deployed, we have remote management capability, and at the same time we can update their software, which is the firmware. So we do design our own firmware. We do all the things related to the firmware intelligence that allows the sensor to move data with very low throughput, and at the same time, which means very low OPEX. And at the same time, we do impose machine learning algorithms that keep the data throughput very low on when we're sensing linear systems. We do have our own manufacturing warehouse, therefore we say that we do everything on our own, and we have a manufacturing excellence. So we design, we prototype, and we go to TRL9 within our own premises. And before delivering the sensor to the market, we do extensive field trial installations, and we try to integrate with all third-party platforms. Therefore, we promote synergies in the IoT landscape. So our excellence is that we are able to rapidly develop prototypes and move them from TRL 1 to TRL 9. So we do a lot of testing, extensive testings in the field. Since we have our own fully owned facilities, we do not outsource anything else than the PCB, meaning that we control the IP property within our company and within our people. We have learned to do business abroad, which is a very nice thing when it comes to developing new products, because you get to know what are the needs of other countries and other markets. Therefore, you tend to commercialize your products, having all the amenities and all the properties that are being requested by abroad. We do impose a highly innovative business model, which allows us to sell sensors, or sell sensors with services, or sell sensors with API. Therefore, we can easily integrate with third-party platforms, and we can do business with third-party companies. This is generally what we're looking for. And thanks God, we have an amazing team that most of them are PhDs. We have a PhD CE that is going to present, my partner that we is going to talk to in a minute. So, and we have, of course, a vast network of professionals that we outsource our jobs when it comes to. So, some things about our clients and the alliances that we do all over the world. So, as you can see in the map on the right side of the screen, we do business all over the world. We do have a significant experience in the Middle East, since this is a market targeting the fuel management, because, as you know, they do produce a lot of oil there. So there we have the biggest client in the area, which is the biggest telecom operator. It's called Attica. We do business with integrators all over the world. We have projects from Cyprus, Greece, and of course the UAE. And we tend to develop synergies with the academia, like the one that we're presenting now, since we do business with digital innovation hubs, and particularly with ahedd, the Demokritos Data and Economy Digital Innovation Hub. Of course, we're trying to expand our networks day by day. Some things about the technology. This is the plainest, the easiest way to understand what we're doing. So let's consider that we do have smart meters, water smart meters. So as you can see on the bottom left of your screen, your house maybe already have a smart meter to measure the consumption of water. So what we do is that we get the data from the smart meter, we transmit it over narrowband IoT networks through a cellular infrastructure. So in Greece, it would be probably Deutsche Telekom or Wind or Vodafone. In other countries, whoever is providing that service, whoever telecom operator is providing that service. So we do send the data over the cloud. They become IP data, and then at the end of the day, they are being shown on a platform where we do provide the platform too for the water company or for the consumers. Therefore, we provide a holistic idea about a holistic data plan covering all from users and up to the companies that are related to the water for this particular example. So in a nutshell, this is all our products that we have been selling all around the world. So first of all, we do design and develop sensors for tanks, mainly for oil tanks, diesel tanks. And this sensor is an ultrasonic sensor. This is our new latest design. This design can be used not only to measure the level of liquids within man-made tanks, but it can be used, let's say, to measure the level of fluids, of water, probably of wastewater or sewage water, like the one that you see here. So we do have an extensive technologies developed regarding water meter retrieve of data using either pulse or wireless M-bus protocol, meaning that we almost connect to 95% of all existing smart water meters, and we get the data out of them, as I showed you before. And we do have our own occupancy sensor, which is a magnetic sensor being used to provide parking management in cities, or anti-parking management wherever you don't want somebody to park. And this is what we're talking about. This is how they're being installed within the earth, within the road. And lastly but not least, I would like to discuss about the Smart Chain project, which incentivized Fuelix in order to design and develop a new kind of sensor, a sensor that will be accompanying food products in order to measure temperature, vibrations, position, and humidity. So this sensor has been developed for the first time in our labs. This is a sensor very different from the sensors that we currently develop, because we do tend to have sensors for industrial use. This is a sensor that can be reconfigured using a mobile app. Therefore, this sensor can be reconfigured by a person and can cortege the products from one point to another, like what you will see here, and what will John, my partner, will be showing you in a minute. So this is, let's say, part of the Smart Chain experiment. Sorry, we just moved it from Athens, from Demokritos to somewhere close, like 200 kilometers away from Athens, and we wanted to capture the position of the sensor along with the temperature and the humidity and the inclination towards this this transport of hypothetical products. And I would like to say that the Smart Chain gave the opportunity to Fuelix to develop the sensor, and I will give the floor to John now, giving the last slide of my deck, which is what we have been doing in Demokritos campus using water meters, and actually what was the modeling of the cloud architecture that we deployed in order to measure data from the campus towards the cloud and then on our platforms. And thank you very much for having us here. I mean, I'm very happy to be able to do this community presentation. I'm giving the floor to John.
Hello from me as well. My name is Yannis Nicolaou. I'm head of cloud and platforms in Helix. Together with Evangelos, we work all day to produce the best experience for our customers in terms of the IoT applications. So here in my screen, you can see the dashboard that we have created specifically for the Smart Chain experiment. The idea there, as Evangelos explained, was to develop a brand new sensor that had components to measure temperature, humidity, inclination, and be designed in such a way to accompany goods that need to be monitored for compliance with specific ranges of these variables. In addition to that, we explored how we could determine the location of the sensor as it moved with the goods from between two different points in an energy efficient way, so that it could be used in a battery operated sensor for a long period of time. There we made various experiments, experimenting with components with direct GPS connection, other ways of updating position, and we finally created a prototype where we actually use the location of the cell towers to determine the location of the sensor, which provides a very good accuracy for the use case that we are looking for. So here you can see how the sensor moved from the southern part of Attica to our workshop, which is in the eastern part of Attica, and this was a course that took an hour or so. So these are the 4 points that were detected by the sensor using the cell towers. After that, we made some other tests moving the sensor from there to the center of Athens. So you can see here how the location is depicted on the map. And finally, we moved it about 200 kilometers north of Athens, and we made the trip to the central part of Greece, and then we came back. And you can see here the tracking of the sensor along the highway, basically, up to the coast in this area and back to our workshop. And along this route, the sensor was measuring inclination, humidity. It made connections whenever it had access to the narrowband network. Of course, it was roaming from antenna, from cell to cell, and provided the data that we expected to get for this use case. So all the data that you see here as an architecture that we follow in Helix are provided over an API. So the same way we create our dashboards, other companies or other projects can use the data to create other value-added services on top of that, or integrate with third-party platforms to do visualization, processing, or training of models. And this is what actually we do actively in Demokritos. So using this API, we provide data for the water meter sensors that are installed there, so that the Demokritos teams can have real life data for the usage of water in their labs and buildings, and use them to train AI models so that they can do anomaly detection, consumption prediction, or other innovative explorations in the water consumption domain. And this is what we can also see here from our own dashboard of our own platform, which again uses the same API as I showed before. And these are some of the buildings where we have installed consumption, water meter consumption sensors. You can see here that we have configured them to make very, very frequent measurements. So it's every 5 minutes. So that the trends and the consumption can be accurately depicted. And then feed the machine learning algorithms that can create additional information based on this. So that is all from my side. Here you can see also on a map where the sensors are located in the Demokritos campus. And thank you again very much for the opportunity for participating in this project. We were very excited and very confident now that we have much more knowledge on this asset tracking capabilities of our sensors, and we are happy to take any questions or comments that you have.
So hello, thank you for organizing this session. I am Theodoros Giannakopoulos. I am a machine learning researcher in the National Center for Scientific Research, Demokritos, and I'm going to talk about machine learning in real-world applications. So let's start with discussing a little bit about the difference between AI and machine learning, because usually these terms lately have been used to more or less describe the same thing. So let's clarify things a little bit. AI has to do with trying to make computers to act like humans, to generally simulate human behavior, and that differs from machine learning, since machine learning focuses on statistical solutions in most of the cases that make computers to learn from real data. While on the other hand, traditional AI has been using logical rules and agents and not generally necessarily statistical solutions. So deep learning, on the other hand, is a subfield of machine learning that simply uses more data and more complicated models to solve the relationships between this data. So we can say that machine learning is a subfield of AI and deep learning is a subfield of machine learning. Starting with the first application domain, we're going to talk about how machine learning can be used in order to detect fraudulent transactions. Now, financial transactions related to fraud have follow some very specific features and attributes that make them differ from legitimate transactions. And therefore, these attributes can be used to discriminate and detect these transactions using machine learning models. This can either be achieved in a supervised or unsupervised manner, depending if you have data or not. And this can be achieved much faster than humans and much better in terms of accuracy than traditional systems that have been using rule-based approaches. Now, moving to the customer service field, we can use machine learning in order to provide faster and more efficient assistance or support to customers, usually through call centers, so or communication procedures in general, like chatbots, etc. And towards this end, we can use automatic speech recognition, natural language processing, and natural language understanding, which are subfields of machine learning applications, in order to either build voice-activated chatbots so that customers can describe what they need and then be directed to some human agent. So using that procedure, we can decrease the waiting time in call centers, for example. Apart from just optimizing the procedure in a call center through reducing time, we can use machine learning approaches like ASR and natural language processing, along with generic speech analytics that recognize emotions and behaviors in the human voice to understand the customer intent and the customer satisfaction. So we can even correlate satisfaction with a particular agent as soon as we have achieved that, and not just a particular agent as a person, but a particular set of agent behaviors and speaking styles that increase the customer satisfaction or decrease it. And based on that, we can extract rules and analytics and even decisions that will optimize the customer service, the call center procedure. Now, keeping the customer side of things, we can use machine learning in order to achieve customer analytics and targeted marketing by analyzing and creating statistical profiles of customers based on their interests, that is their previous transactions, or even some metadata such as demographic data, etc. So we can build based on this information machine learning based recommendation systems in order to automatically propose particular products, optimize the marketing campaigns that are more targeted, etc. So this recommendation and profiling set of applications uses machine learning to build customer specific models. And moving to the retail section, today we can build retail applications that are related to a particular product or a particular sector. For example, this Sephora virtual assistant can try lip color. You can make the customer try lip colors and makeup products. And in a similar content, in a similar context, smart mirrors use machine learning methods to detect the customer's body and make an augmented reality interface where the customer can try different clothing, for instance. In the same field of retail market in general, but a slightly different application, not customer oriented, but business oriented, we can use machine learning to utilize data from cameras and sensors to analyze customer trajectories in shops and therefore use machine learning to predict behaviors and shopping habits of the customers. And therefore we can use this data to optimize product location. This is something that has been done for several years in the supermarkets, but in a manual manner using traditional marketing rules and psychology. Moving to the core industry, we can achieve quality assurance by utilizing sensorial and multimodal data from cameras and microphones to optimize any type of production company that creates some type of equipment or controls a process plant. And we can use this data to even measure and predict the production quality. So machine learning can be used either to predict the production quality or to predict the risk of the product quality related to some particular variable of the production pipeline. And based on that, the machine learning methods can even predict which part of the production pipeline should we optimize to increase to decrease the risk. As an example here, computer vision is used to detect corrosion damages and cracks in industrial pipelines, or we can even use sound recognition to analyze the sound made by a drill to detect misfunctioning drills here. In this particular example, the misfunctioning drill is on the left, on the right of the slide. Similar technologies have been used in the shipping industry to detect engine faults and the problematic pipes through analyzing the sound they make while functioning. Moving to the agriculture domain, drones and cameras and static sensors have been used to monitor crop and soil and to detect malnutrition or even plant diseases based on the texture of the images of the plants, and they achieve that in a bigger scale and much faster than humans. In this particular example, computer vision is used to observe and recognize crop maturity. Now, moving to the smart cities and smart building domains, I won't say many details on that because Yannis and Vangelis have already described the Fuelix approach. I'm just going to say that we have a strong cooperation with Fuelix in the context of water consumption analytics. Fuelix has installed a set of sensors has actually installed in the Institute of Informatics and Telecommunications in Demokritos and in the central water consumption of the whole center. And we have used the Fuelix API in order to build a machine learning driven platform which can be used to apart from predict future consumption, to detect outliers in consumption, which is obviously important for decision making, for detecting problems in the water systems, etc. And moving to a bigger scale, from smart buildings to smart cities, multisensorial data can be used to analyze any type of information that can be gathered from a city, such as assessment of public spaces quality, like the air quality and the sound quality, or even achieve surveillance either for security or safety through cameras and microphones. As an example, in Demokritos, we have been working during the last years in methods that automatically analyze the quality of the soundscape through analyzing multiple microphone sensors that from low quality microphones that have been spread across the urban space, and we automatically recognize the level of the soundscape from 1 to 5, with 1 being the worst soundscape and 5 being the optimal soundscape. So this can be used to detect trends and statistics in a huge city like Athens, and based on these statistics, export decision making proposals and recommendations. So moving to the human resources domain, machine learning can be used both in the recruitment and the internal human resources procedure. Natural language processing can be used to speed up the recruitment process by analyzing CVs, or even we can use speech analytics to analyze emotions and behaviors of the persons participating in the interview, recognizing if they are extrovert or they have any other soft skills. And the same technology can be used in the internal human resources procedure to analyze behaviors, dialogue dynamics, personal development attributes of the persons that participate in one-to-one meetings or Scrum meetings or company presentations. And finally, creativity has also gained from the machine learning and deep learning era. Lately, there have been models that create images, photos, paintings, sounds. I'm quite sure you are all aware of the deep fakes, for example. Now, this technology can be seen as a new tool to easily create content for commercials, for marketing campaigns, by minimizing the cost, as there is no need for licensed content in that case, and by also increasing effects capabilities without necessarily having very deep background knowledge in 3D creation, etc. Now, using machine learning and deep learning in real-world industrial applications is feasible today. First of all, because there are a lot of people working in the machine learning domain. We have really huge human resources, both here in Greece and internationally. Second, we have computational resources. Today's computers and GPUs especially are much faster than they used to be in the past. Therefore, we can use much more complicated models. Third, we have data resources. We have tons of data that can be used to train, especially the supervised models. And many of these data are also available to smaller companies and SMEs and even individuals in many cases. And finally, we have a huge community that has been working in the deep learning section for several years. And this is expressed through a set of open source libraries and open source models that are made available to the public. Despite that, there are many challenges. First of all, off-the-shelf solutions and models are not always the best solution for real world applications, as the existing models are too generic for industrial specific and domain specific problems. Second, computational cost is low today, but it can be very high if we don't take into consideration the optimization of the development and the deployment process of the deep learning models. Also, we need to consider domain specific specifications, such as requirements that characterize edge computing applications, where we cannot actually build and deploy a model that is, for instance, I don't know, some gigabytes of size for obvious reasons. For these reasons, we need to build some common language between the machine learning experts and the domain experts to achieve this AI transformation, as they call it. To put it simply, we need to make domain experts more data-driven, and at the same time, we need to make machine learning experts more business target-driven. We need to always, I mean machine learning experts, we need to always have in mind that business-related KPIs need to be expressed when we evaluate the performance of a machine learning model, for instance. And this common knowledge, this common language between machine learning community and the industry community needs probably years to be built, but it's something very necessary to build applications, machine learning applications that actually add value to the industry domain. So thank you very much.